I'm recording. Up to this point in your life, you have probably always used rectangular coordinates. What are rectangular coordinates? Longitude, latitude is a good example of rectangular coordinates, yes? Well, rectangular coordinates, like x and y. So if I give you this point right here, you might tell me this point is the point, well, it looks more like 4, 2. It's further to the right than it is up. So this one looks like it's maybe 4, 2. And this is known as rectangular coordinates because you're measuring this way. So you get a big rectangle here. So it's 4 over and 2 up. That's called a rectangular coordinate. Today we're going to talk about a different way of labeling points called polar coordinates. What's that? Sailors, no. Sailors don't use polar coordinates. They use something similar to polar coordinates, but not exactly. Sailors tend to use bearing. And so sailors, if they need to go this direction, they measure it from here. So this would be maybe north. So you start with due north, 60 degrees towards the east. So that's how sailors and pilots measure things. They measure things from either true north or true south. Bearing. This is called a bearing. Sailors and pilots tend to measure things that way. All right. Anyway, polar coordinates, the way we're going to measure, the way we're going to label points is if I draw a point here, I'm going to measure the distance from the origin, and that's called r, and r stands for radius. And then we're going to measure this angle, and we're going to call that theta. So this point right here, instead of calling it x and y, we're going to call it r and theta, where r is the radial distance from the center, and theta is the angle. Questions on that? Why? We'll see why. Not today, but soon. Like Monday. We'll see why we might want to do things like this. All right, this point. If I call this point 4, 2 in rectangular coordinates, can I call it anything else? Or is it unique? Is this the point 4, 2, and anything else would be a different point? Anything else would be a different point. Okay. In polar coordinates, that's not true. No, it's not the slope. It's just the distance. So this distance is r. So this point is maybe the point 4, pi over 4. So that would be a polar point. What that means is the length of this thing is 4, and this radius is pi over 4. However, no, traditionally when you write polar points, you write it in radians. Could you write it in degrees? I suppose you could. But traditionally we use radians, unfortunately, for this whole section. Yeah. This is also the same as 4, 9 pi over 4. That's the exact same point, even though it has a different angle. Correct. There are a different number of answers. Why is 4, 9 pi over 4 the same answer? Correct. All I did is I went one full revolution around. There's 2 pi, and then I went pi over 4 more. So you are correct. The point 4, pi over 4 has an infinite number of representations. I could also use a negative angle, couldn't I? I could call this 4, what would the angle be if I went negative? Negative No, 9 pi over 4, negative 9 pi over 4 would become all the way around and then go a little more. It is 7 pi over 4. So you are absolutely correct. There are an infinite number of ways I could label that point. Using positive angles, using negative angles, using any number of revolutions that I want. So that's kind of weird. In rectangular, the point 42 is the point 42 and there's nothing else you can call it. In polar, any point has an infinite number of correct answers. Well, we're getting to that. That's Monday. Oh, the 4 can change too. Yeah, so here's a weird thing. This point, 4 comma pi over 4. Well, it could be the square root of 16, but that's just a fancy way of writing 4. The other thing we could do is measure this angle. That angle in quadrant 3. How much is that angle in quadrant 3? 5 pi over 4. So if I wanted to use the angle 5 pi over 4, then we would call our radius negative 4 to go back that direction. So we could also call this the point negative 4, 5 pi over 4. But that's the only way r can change. R can be positive or negative, and that's it.
Yeah, but
it always stays 4, but it could be positive or negative. Questions on that? All right, so what I've given you here is what's typically known as a polar grid. So we're going to, these going out, you have the radius of 1, 2, 3, 4, 5, 6, and then we have our angles marked. So the point 4 comma pi over 4, that's the one I've been using. You go to the angle pi over 4, then you go out 4 radiuses. 1, 2, 3, 4. So there's the point 4 comma pi over 4. Where's the point 1 comma 0? The angle is 0, so you go, which way do I go out 1? Straight 1 to the right. So the point 1, 0 would be the point 1, 0, just like it is in rectangular. It would be the same thing, 1 to the right. How about the point 3 comma negative 2 pi over 3? Correct. So here's, if I go backward, this is negative pi over 3, and then this would be negative 2 pi over 3. So it would be here at 4 pi over 3 as a positive angle. And then I would come out 3 spots. 1, 2, 3. No, if this were negative 3, negative 2 pi over 3, I would come to 2 pi over 3, and then I would go the opposite quadrant if that were a negative in front. Like this one is. This one has 5 pi over 6.
So you just go the other way.
You go the other way. So for this one, I go to 5 pi over 6, which is here. Instead of coming out to this way, I go out to the opposite direction. So 5 pi over 6 is here, but because this is a negative, I'm not going to mark it here. I'm going to go this way.
So that can be written as like 2 11 pi.
So this is also the point 2 comma 11 pi over 6. Absolutely. Absolutely, it could be written that way. Looks like what?
It looks like a radar arm instead of
It looks like a dartboard to me. That's what I see when I look at these. I see a dartboard. Yeah, it does look like a radar thing too.
Do they actually use it?
No, but again, when they're dealing with radar, they do use something like this, but again, they usually measure from north. So they'll say something is north 45 degrees east at 200 miles. So they're giving you the radius is 200 miles out that direction, but then again, they measure it that way instead of we always measure from the x-axis. Map coordinators play Battleship. All right, number 2. Give two polar representations of the form 2, 3 pi over 4. So basically, how else could you write this point? 2, negative 3 pi over 4 wouldn't quite work, because let's mark it here on our graph. 2, 3 pi over 4 would be right here, but 2, negative 3 pi over 4 would be on this side. No, I'm sorry, it would be over here. Negative 3 pi over 4 would be over here. So that would be the point 2, negative 3 pi over 4.
Negative 2, 7 pi over 4.
One correct answer looking at the graph would be negative 2, 7 pi over 4. So you go to 7 pi over 4, you go the opposite direction. That would work.
Oh, and
To 11 pi over 4. And how did you get 11 pi over 4? You did what?
she added 2 pi.
You add 2 pi. So if you add 2 pi, you get 8 pi over 4, which added would be 11 pi over 4. So that would be another way to get the answer. You could add 2 pi, you could add 2 pi again, you could have subtracted 2 pi, you could have subtracted 2 pi again. There's lots of ways to get correct answers. Again, there's an infinite number of correct answers. Convert. All right, we're going to talk about that first. I'll draw some pictures here. All right, so let's say I give you a polar point. I give you an r and a theta. And I want you to tell me what that is in rectangular. In other words, I want you to give me the x and the y. So this would be the same as some x value and some y value. How are you going to find the x and the y? Distance formula? No distance formula. Count. No, we can leave things in radians. You don't need degrees. How about I tell? All right, well, what I'm going to do is I'm going to draw a little triangle here. What's this height right here? That would be the y, wouldn't it? That's the y value right there. And how about this distance over here? That would be x. If I know r and theta, how can I find x? X would be cosine. So cosine of theta would give me x over r. So x is r cosine theta. So if I give you a polar point, you can very easily give me the x in rectangular. X is r cosine theta. What about y? It would be the same thing, right? You'd have sine theta is y over r. So y is going to be r sine theta. Okay. So let's see. The point 6, 2 pi over 3. Convert that to rectangular form. Well, x is r cosine theta. So that's going to be 6 cosine of 2 pi over 3. That's 6 times, what's the cosine of 2 pi over 3? Negative a half, because 2 pi over 3 is in quadrant 2. So this is 6 times negative a half, that's negative 3. Conversely, the y value is y equals r sine theta, which is 6 sine 2 pi over 3. That's 6 times. What's the sine of 2 pi over 3? Square root of 3 over 2? That's what you said. That's correct. And it's positive because we're in quadrant 2. So 3 square roots of 3. So this point, 6, 2 pi over 3 in polar form is the same as negative 3, 3 square roots of 3, in rectangular form? Questions on that one? All right. Well, once you do that once, the rest of these aren't too bad. Uno momento. Okay. Good now? All right, for part B, x is going to be square root of 2 cosine negative pi over 4. That's square root of 2 times, what's the cosine of negative pi over 4?
Square root of 2 over 2.
I heard both for negative square root of 2 over 2, and
Negative square root of 2 over 2.
I heard both for positive square root of 2 over 2.
It's negative square root of 2 over 2.
I see a head shake over there. Nate says no. Negative pi over 4 is in quadrant number 4. In quadrant number 4, cosine is positive. That's correct. So it should be positive square root of 2 over 2, which is a fancy way of writing 1, because the square root of 2 times the square root of 2 is 2. 2 over 2 is 1. Conversely, y is going to be square root of 2 sine negative pi over 4. That's square root of 2. What's the sine of negative pi over 4? That one would be negative because sine is negative in quadrant 4. So that would be negative 1. So, the point square root of 2 comma negative pi over 4 in polar form is exactly the same as the point 1 comma negative 1 in rectangular form. All right, how about C? That's not that hard at all. What's the answer? It's 3 and 0. It's exactly the same. Think of it as a graph. This means go 3 to the right, and your angle is 0. Yeah, when you have zeros here, these are very easy. This means go 3 to the right, and your angle is 0. If you go 3 to the right, and your angle is 0, that's the point 3 comma 0 still, isn't it? Doesn't matter if it's polar or rectangular. 3 0 is 3 0.
Anything 0.
Anything 0 is anything 0. That's correct. All right, now we're going to go the other way. Now we're going to convert rectangular into polar. All right, so I got to draw some more pictures here. This time, let's say I give you a point, and I tell you this is x comma y. If I give you x and y, how are you going to find r and theta? What you're doing is you're drawing the triangle again. This is y, this is x, and you're telling me tangent of theta is y over x. So in other words, theta is going to be tangent inverse of y over x. And then how am I going to find r? Sine over cosine, I could do that, that's too hard. How am I going to find r? Pythagorean theorem. Yeah, it's a Pythagorean theorem problem. X squared plus y squared is r squared. All right, so there's the two formulas you need. If I give you rectangular stuff and I want polar, you need those two formulas. Now, you do need to be careful. What you need to be careful about is when I use this tangent inverse button on my calculator, or if I use tangent inverse in my head, no matter where I do it. Sometimes it'll give, on a calculator, it'll give us a decimal. Sometimes we might recognize it as a special angle and know that it's pi over 4 or something like that. But my point was going to be, when I do tangent inverse, where do I get answers? Which quadrants does tangent inverse play in? 4 and No. No. 1 is the only one left. All of the inverse things use quadrant 1. Some of them use different quadrants. So, if I use this tangent inverse thing, it's always going to give me an answer in quadrant 1 or quadrant 4. What if my point started over in quadrant 2? I'm going to have to fix it. I'm going to have to do a reference thing or fix it somehow. So you do need to be careful of that. All right, so let's look at the problems we have here. So I have 3 square root of 3 comma negative 3. That's a rectangular point. Which quadrant is that in? That's in quadrant 4. So we're okay. Tan inverse works in quadrant 4. We're going to get the right answer. All right, so we're going to have theta is tangent inverse of y over x. So that's tangent inverse of negative 3 over 3 square roots of 3. That's tangent inverse of negative 1 over the square root of 3. Is that one of our famous ones? Yes, although it's not written the way we usually write it. This is usually written as tangent inverse of negative square root of 3 over 3. Multiply top and bottom by square root of 3, rationalize. So it is a famous one. What's tangent inverse of square root of 3 over 3? Pi over 6 over 3 is correct. I'm pretty sure it's pi over 6 too. It is, except this negative is going to do what? Make it negative. It's going to put it in quadrant 4. So our angle is negative pi over 6. And I'm going to find r. R squared is x squared plus y squared. So that's going to be 3 square roots of 3 squared plus negative 3 squared. What's 3 square roots of 3 squared? 9 times 3, which is 27, plus 9, which is 36. So r is 6. So in polar, this is the point, 6, comma, negative pi over 6. Yeah, could be bigger than 6. I mean, the graph that I gave you only went to 6. But of course, I could draw more circles and go 7, 8, 9, 10. Yeah, I could go out as far as you want. All right, this point. Negative square root of 8, comma negative square root of 8. Which quadrant is that in? Quadrant 3. So I'm going to have to fix it this time. I'm going to have a problem. Let's do the r first. R is never a problem. R squared is x squared plus y squared. That's going to be negative square root of 8 squared plus negative square root of 8 squared. So the answer is 8 plus 8, which is 16, and then I do the square root. You're right, r is 4. Theta is the tangent inverse of y over x, but that's going to be the tangent inverse of 1, isn't it? Because y and x are exactly the same thing. What's the tangent inverse of 1? It's pi over 4. So theta is pi over 4. And you can see the problem that we have. Theta is pi over 4, which is in quadrant 1. But our original point was in quadrant 3. So we have two choices. One choice is we add pi to this angle. So one correct answer would be 4, comma, 5 pi over 4. That's one way to fix it. Or the other way to fix it is leave the pi over 4 alone.
Oh, because it's in quadrant
and make the radius negative. So that's what you're going to have to do. If your original point starts in quadrant 2 or 3, you have two choices. You either add pi to your angle, or you leave the angle alone and make your radius negative. But they're both correct, and I don't care which answer you give me because they're both correct. Okay? But you need to remember that. And I'll see this all the time. I'll give this problem on a test, and people will give me the answer 4 pi over 4. They'll forget that this point started in quadrant number 3. You've got to give me the answer in quadrant number 3.
Like, so anytime it's these numbers, we have to give the answer that starts with 1
Yes. So this point is in quadrant 3. So this answer has to be in quadrant 3. You can't give me a different quadrant. That would be a different point. Okay, how about this last one? Negative 2 comma 1. Which quadrant is that in? Quadrant 2. So we have the same issue, don't we? We're either going to fix the r or fix the theta when we get to it. All right. But again, once you know that, they're all pretty much the same. R squared is x squared plus y squared. So it's negative 2 squared plus 1 squared. So r squared is 5, which means r is the square root of 5. Theta is going to be tangent inverse of negative a half because it's y over x. A half, is that one of our famous numbers? It is, but not for tangent, unfortunately. A half is a famous number for sine and cosine, not for tangent. Crap. So what do? I use my calculator. So tangent inverse of negative a half, my calculator says about negative 0.46. But again, we started here in quadrant 2. This angle that I just gave is really in quadrant number 4. And I did check to make sure I'm in radians mode. Make sure you're in radians mode. All right, so how do I write my final answer? How do I fix this? I've got my r, and I've got my angle, but it's not right. Because this is in quadrant number 4, where this original point, oops, this should have been this way. This original point's in quadrant number 2. So how do I fix it? I have two choices.
Just to make the r negative.
I can make the r negative, or add pi to that angle. So neither one's too hard. So two correct answers. I would accept negative square root of 5, negative 0.46, or leave the square root of 5 alone and add pi. 0.46 plus pi, 3.14 is 3.6. So I would accept those two. I do have a pi button, but I just show, since I'm rounding to 2 decimal places, I just use 3.14. I rounded it to 2 decimal places. I do have a pi button. See, I could have done 0.46 plus, there's a pi button right there.
It's
negative.
It's negative. So it's going to be 2.7.
Oh yeah. I didn't do the negative there. Bad teacher. 2.68. All right, so the last thing we have in this section, I think. Yeah. Not only can we convert points, we can also convert equations. So for example, I might give you the equation x squared plus y squared equals 9. That's an equation in rectangular form. That gives you x squared plus y squared is r squared. So this equation in polar form is r squared equals 9. So r equals 3. Yeah, it seems weird because it seems like there should be a theta too, shouldn't there? So what this means is, since there's no theta in the equation, theta can be any value in the whole wide world that you like. These not a number.
3.
So you pick 3. I pick 5. Somebody else picks 2 pi. Oh, you just write r equals 3 as your answer. What does this graph look like if the radius is 3? It's a circle, yeah. So this is, it says the radius is always 3. Doesn't matter where you are. So this equation is one circle with the radius equals 3. If theta can be anything. No, you don't have to draw it. But it's kind of nice that here we have this equation, x squared plus y squared equals 9. That's a little bit, a little bit confusing in rectangular form maybe. You put it in polar form, it looks very easy. R equals 3. R equals 3 is a circle.
I think the word radar.
I'm sure that the word radar comes from radius, yes. Yeah. All right, how about y equals x squared? How can we write that one in polar form? I'll give you a hint. What's y? And what's x? Right. So what am I going to do with this y? I'm going to write r sine theta. R sine theta equals the other one, r squared cosine squared theta. Remember what we did before? We looked at this picture and we learned that x was always r cosine theta, y was always r sine theta.
So you just squared both things.
So I squared both things, correct. I just squared both things. Now, what we do like to do if we can, we do like to take these equations if we can and try to get the r all by itself. Do you think you could get the r all by itself on this one?
Yeah. Move this r line over and then back the r.
Yeah, that doesn't quite work though. You're close. This would be r squared cosine theta minus r sine theta equals 0. When I factor the r out, I'm going to have r cosine theta minus sine theta. And then divide by r. Yeah, again, dividing by r is kind of a bad thing. How come dividing by r is kind of a bad thing? R could be 0. All right, so this one, I don't think there's a good way to get the r all by itself. So I think I would just leave it like so. The next one I think we'll be able to do something with though. All right, so what am I going to do with the next one? What's x squared? R squared cosine squared theta. Minus, what's y squared? R squared sine squared theta. Now, this time I can factor the r squared out, can't I? So r squared times cosine squared theta minus sine squared theta equals 1. And then can I get the r all by itself? Yeah, I can. Well, I can get the r squared by itself, I suppose. R squared is 1 divided by cosine squared theta minus sine squared theta. Again, I'm not thrilled with that because I had to divide by something with variables in it, which could, of course, be 0. But what's going to happen? What's going to happen if this is 0? What happens when you get a number 1 and you divide by 0? It's undefined. What happens in your graph? It explodes. You get an asymptote. You get a vertical asymptote of sorts. So this graph has some vertical asymptotes is what we're seeing because we might have divided by 0. All right, finally, we go the other way. What if I give you a polar equation and I want you to write it in rectangular? Do what? Hard pass? No, you don't pass.
49.
Square both sides. R squared is 49 And then you're exactly right. X squared plus y squared is 49. So that's a common thing that we have to do quite often. We have to square both sides to give ourselves an r squared. We like to do that. Oh, how about the next one?
Well, theta is inverse again.
Say that again.
X over y.
Theta is inverse tangent of y over x.
Do we have to?
I don't know. Are they on that formula sheet that I gave you? I don't know. I don't know if they're there or not. But you're absolutely right. If I do tangent on both sides of this, I get tangent of theta is y over x. So that's what I'm going to do over here. Tangent of theta is y over x. So tangent of minus pi over 2 is y over x. What's the tangent of minus pi over 2?
No, it's not. It's undefined.
It is undefined.
I'll choose one.
So how do I have undefined equals y over x? What the heck is that?
Something you might write here.
All right. Let me ask you a different question. What if I were to graph this? What does negative pi over 2 look like?
Pi over 2. Pi over 2.
Is that angle? Negative pi over 2? So this is our angle, negative pi over 2. R can be anything I want. So since R can be anything I want, what I'm really looking at in this case is that line right there. So theta equals negative pi over 2 is really a fancy way of saying the y-axis. What's the equation for the y-axis? X equals 0. Yeah, this is a vertical line. Vertical lines have a special equation, x equals 0. So normally if you have theta equals a number, this is what you're going to do. Unfortunately, it doesn't work for this one because it's a special angle. Your answer is x equals 0. Yeah. Draw a picture and see that you get a vertical line. If it's any other angle besides pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, it's going to work. You just use tangent on both sides and you get the right answer. All right, the next one. R equals 4 sine theta. Any clever ideas with that? Square both sides. If I square both sides, I'm going to get r squared over here. That's a good thing. But I would have sine squared over there. I don't think that helps. But you're close. I like having the r squared. I wish I had an r sine theta. Because r sine theta is a fancy way of saying y. So what's a way to get a r sine theta right there? Multiply by r, but if I multiply by r over here, it gives me r squared again still. So this is another very common technique in these problems. You multiply both sides by r. And that gives us r squared equals 4r sine theta. R squared is x squared plus y squared. And r sine theta is y. So we get x squared plus y squared equals 4y. All right, I'm out of time for today. Go home and try that one. We'll start there on Monday. See if you can come up with an answer for that one.